Today in this lesson we're going to do section 4.3. It's called function notation. Now, when working with several functions, it can be confusing to distinguish among them if they all begin with y equals. So that's why we use function notation. Function notation can be used to help figure out which function you are dealing with. So if you look at this chart right here, if everything was always y equals, y equals, y equals, and then I ask you to evaluate the function, you would have no idea which function to choose from here. But if it is labeled with f of x or g of x and so forth, you will know exactly which function anything is referring to. So if you look here in the middle, you need to keep in mind that when you see this, I know it looks like multiply, but it is actually not multiply. This is read f of x, and f of x is basically equivalent to y. It is replacing the y. It's almost giving the function a name. So f is the name. Over here, g, h, m, and j would be the names. The input variable is always the x. So this math tip right here, it says notice that f of x equals y. For a domain value x and the associated range value is f of x. Now let me explain that just a little more. If you make an input-output table, you will no longer use y, you will use the function name. So you need to keep in mind that x is the input, it goes in here and here, and f of x is what's the output is going to be. So why do we even use function notation? Well, function notation is useful for evaluating functions from multiple input values. So here we are going to put evaluating. Now, as you look at the next box, it says use different functions to evaluate the given value. So you have 6 boxes listed below here, and I'm going to give you different values, and as soon as I give you a value, I'm going to reference the function. Then you will know exactly which function I am talking about. So for number 1, we are going to evaluate g of negative 2. Now that tells you that you need to find the function g of x, which is right here, and it tells you to input the negative 2 in for x. So you would say g of negative 2 is equal to 5 minus 2 input negative 2. Now what this tells the reader is that the function g is being evaluated at negative 2. So g of negative 2 is equal to 5 plus 4, so g of negative 2 is equal to 9. Now, if you're reading this, this is how this reads. The input, x equals negative 2, produced the output of 9. Now notice, I did not say y equals because now it is g of x equals, and in this case it is g of negative 2 equals 9. Now for number 2, I would like for us to evaluate h of negative 3. So you would look at the top in your function bank, find h, it is right here, and you would say h of negative 3 equals 2 times the input negative 3 squared minus 1. Remember to be very careful, order of operations. H of negative 3 is 2 times positive 9 minus 1. So h of negative 3 will give me 18 minus 1 for a 17. Now remember the notation. The function h was evaluated at negative 3. It produced the output of 17. Now I would like for you to do number 3. I want you to do the function p of 2. Pause the video and try it. Now for p of 2, you would use this function. So you would say 1/2 times 2 cubed. Once again, apply your order of operations. So this would be 1/2 of 8. So p of 2 would produce a 4 for the output. Now, that is evaluating single functions for the given inputs. Now, for the next questions, we are actually going to do multiple problems at one time. So for number 4, I'm going to ask you to do g of 2 subtract f of 3. Now, do not let the notation confuse you. The easiest way to kind of accomplish this problem would be to do 2 separate problems. So you would cover up this one and you would do g of 2 first. So g of 2, we find g. It is 5 minus 2 times 2. I got g from up here in the bank. And you would simply do g of 2. So g of 2 would be 5 plus 4. So g of 2 would be 9. Now, don't do anything. Ignore this one now. Now do f of 3. f of 3 is sticking a 3 in for x, and the x is negative. It is right there. So f of 3 is negative 3. So what we have done is we have figured out g of 2 is equal to 9, and f of 3 is equal to negative 3. Now we perform the problem. It says g of 2, which is 9, subtract f of 3, which is negative 3. So then 9 subtract a negative 3 would be 9 plus 3 for an answer of 12. Now let's look at another one. Question 5. I want us to look at m of 3 plus g of negative 3. Now I would like for you to pause the video and try this one. Remember to separate it, then do the operation. Okay, I have worked out m of 3 and I have 6, and I've worked out g of negative 3 and I have 11. So the operation in the center is add, so I'm going to say 6 plus 11, and I'm going to get 17. Now I would like for you to try one more, question 6. I would like for you to do j of 5 times p of 1. Once again, pause the video and try this problem. Okay, I worked out j of 5. I substituted 5 into the function. I have 9 subtract 5 squared. So I have 9 minus 25 for a negative 16 for j of 5. Over here I have p of 1. I substituted 1 into the function p. I ended up getting 1/2. Now if I look at the operation, it tells me to take the value of j of 5, which is 16, multiply it with the value of p of 1, which is 1/2. Negative 16 times 1/2, that will give me the value of negative 8. So in review of this section, the only thing that function notation can help us kind of do is to help us stay organized. It helps us know exactly which function we are dealing with, and we need to understand that the x is the input, the f of x is replacing y, and we consider that to be the output. Now, if you would flip your paper over, go to the top of the page, and now we are going to relate this to everything we've been talking about so far in this chapter. So at the top of the box, it says use function notation to evaluate f of x equals 3 minus 2x for these 4 input values. So what I would like for you to do first is I would like for you to evaluate at f of 3. I would like for you to do f of 0. Then I would like for you to do f of negative 1. And then last, f of 1.5. So I would like for you to pause the video and work these 4 problems out before we move on. Okay, now let's check your answer. You can see what I have done. For f of 3, I did the input of 3, I did the input of 0, the input of negative 1, and the input of 1.5. I generated this output for each of these. Now, what you must be able to do is to take the function notation and relate it to everything we've been doing. Are you able to write an ordered pair from this notation? Are you able to take the table of values and the map and the graph? So it really all starts with writing an ordered pair from your function notation. So it tells me to do a list of ordered pairs. So we are going to use set notation, and we are going to write 4 ordered pairs. So remember, x is the input, f of 3, which is f of x, is going to be the output. So my first ordered pair is going to be 3, negative 3. The second ordered pair will be 0, 3. The third ordered pair will be negative 1, 5. And the last ordered pair will be 1.5, 0. And that is the list of ordered pairs. Now, once you get the ordered pairs, you can also make a table of values. Now, once again, remember that y is really f of x. So we have 3, 0, negative 1, and 1.5. That's the input. The output that we got was negative 3, 3, 5, and 0. Now, the same thing goes for the map. You have 3, 0, negative 1, 1.5, with the output negative 3, 3, 5, 0. Now, from the graph, we would just graph our ordered pairs. We have 3, negative 3. We have 0, 3. We have negative 1, 5. And we have 1.5, 0. So we have the graph here. This is our list of ordered pairs. So function notation, we're doing the same thing. It's just a new notation. You just need to understand how it works and how to read it. Now, we need to think backwards at this point. It says, what value of x results in f of x equals 4? Now, I need you to understand what I said at the beginning of the video. I said that f of x is replacing the y. So when I'm asking you what value of x results in f of x equals 4, I'm asking you what went in here to give me a 4 right here. So we're going to have to work backwards and we're going to have to understand the notation. So let's write our function down. We are working with f of x equals 3 minus 2 minus 2x. Now, what value of x results in f of x? Well, notice I have a box around f of x. Well, here is f of x. This is telling me that f of x is equal to 4. So what I can do is I can take this 4 and replace that entire box with 4. So I'm going to take f of x out and I'm going to put a 4 there. And I'm going to go ahead and write my function down. Now what I have created an equation that I can solve. So I'm going to subtract 3. I get 1 equals negative 2x. I'm going to divide by 2. And I'm going to get x is equal to negative 1/2. Now, if you will check this, you will see that it does in fact give me 4. So let's check it by plugging it in. F of negative 1/2 would be 3 minus 2 times 1/2. And it's negative 1/2. So this would give me 3 plus 1. So f of negative 1/2 did in fact give me 4. So the input, the x value that gave me 4 would be negative 1/2. So on this one, what I would like for you to do is to try to find the value of x that results in f of x equals negative 0.5. Pause the video and try. Okay, let's check your answer. Here I have my f of x boxed. I'm going to replace this box with negative 0.5. I'm going to continue to write my function down. I'm going to subtract 3. I'm going to get negative 3.5 equals negative 2x. I'm going to divide by negative 2. And x is going to be 1.75. So 1.75 gives you the value of negative 0.5. Now, just to kind of check to make sure we're right, let's go ahead and check these two to see if they fall in the line of this graph here. So this one says negative 1/2, 4. 1, 2, 3, 4. Notice how it falls in that line. And this one was 1.75, negative 0.5. So 1.75, negative 0.5. So you can see those are the correct input-output combinations because they are all in common on that line that would be made if we connected our discrete points. So now let's move on. We've done the algebra part of it. Now let's go ahead and look at the graphing part of it. Okay, so in this situation, it says use the graph to find the following values. And you simply have a graph. It's labeled. You have your x and y axis here. But we're going to make this a function. So I'm going to ask you 4 questions, and I'm going to see if you're able to read the graph to figure out the values. So the first thing I'm going to ask you to do is to find f of negative 2. Now what I'm asking you to do is for this function, find the output when the input is negative 2. So we would go over to our graph and we would look for the input. Remember, x would be the input, and we're going to find a negative 2. And you can see the input of negative 2 gives me the output of 0. So the answer for this one would be 0 because the ordered pair negative 2, 0 is on the function. Now you try f of 0. Okay, so now if you look at 0, here's 0, and look at your function, f of 0 gives you the point, the ordered pair 0, 4. So 0, f of 0, the output would be 4. Now, that's when you are given the input, you find the output. Now, what if I ask you to go backwards? What if I ask you to find x when f of x was equal to 0? Now, let's stop and think about what this notation is asking you to do. This is asking you to find the input that gives you the output of 0. So, as we look at the graph, here's the input, and the output would be along this line. Well, here is 0 on the line. So I have a 0 output here, 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 and here. So there are actually 4 values of x that give me the output of 0. And they are when x is negative 2, as we saw right here, when x is negative 1, when x is positive 1, and when x is 2, they give me the output of 0. Now, the next one I'm going to ask you to estimate. So x when f of x is equal to negative 2.25. So here things are not exact, but we can still go ahead and find the output, okay, where the output's negative 2.25, but find the input that gave me that. So we go to the f of x here, and we go to negative 2.25, which is right here. So there's one here, and there's one here. Now, that's the output. What input gave me this output right here? So I look here, and I would guesstimate that that is about positive 1.5, and this one here is negative 1.5. So the input that gave me this output is negative 1.5 and 1.5. So you constantly have to think of input and output when you're doing the graph. The input is always on your x-axis, the output is always on the y-axis. So now we've looked at the algebra part, we've looked at on a graph. Now it's time to look at a real-life situation. Now in this situation, it's very important to kind of figure out what's going on. You've got to know your domain and range, and you've got to pay attention to the detail and follow the directions. So it says, a bowling alley charges $5 to rent shoes and $4 per game. However, this price is only good for up to 4 games. So right there, they're restricting our domain. The cost after playing X games is given by this function. Okay, so f of x equals 4x plus 5. So $5 to rent our shoes, $4 per game. So it says, what does f of x represent? Now, remember that f of x is the output. So it is over here. And remember that the input will be x. So before we even talk about part A, let's label these x and y axis because that will tell me what f of x represents. Well, x says it's the games, playing the games. So x is going to be the number of games. Now, as we play a game, f of x is going to be the cost of playing the games. So when it says, what does f of x represent? Okay, it is going to be the cost of playing each game. Okay, and keep in mind that it's going to be the total cost. Okay, now it says use a table to evaluate the function for 1, 2, 3, 4 games. So we are going to use a table. We're going to label it x, and we're going to label it f of x, not y, because we're in function notation. So we're going to input 1, 2, 3, 4. So for one game, it is quick and easy to evaluate because at one game, if I put 1 in there, I'm going to get 9. So it would be $9. If I put a 2 in there, you can clearly see it's going to go up by 4, so that's going to be 13. F of 3, of course, is going to give me 17. And F of 4 is going to give me 21. Now, remember, this is the games I am playing. This is the total that I am paying. Part C says to graph the function. Now, we always want to label the x and y axis. We've already done that. So now we need to come up with a scale. So the number of games, we are going to stick with 1. Now, over here we have 9 to 21, so I think it would be very practical to probably go by, let's go by 4s. So 4, 8, 12, 16, 20, 24. Now you can make that scale anything. It's just 4s will get us a pretty good picture. So one game is $9. 2 games will be $13. 3 games will be $17. And 4 games will be $21. Now we are going to use discrete situation here. We are not going to connect them because we are paying per game. We would not pay for 1.5 games. So we've graphed the function, we've used the table. Now it says identify the domain and range. So the domain, remember, is going to be the input. So the context here is going to be the number of games. The problem clearly told us we were going to play 1 up to 4 games for this price. We are not going to use interval notation. We are going to use roster notation, set notation. So we're going to go 1, 2, 3, 4. Now the range is going to be the total that we pay. So we're going to be in money here. So it's going to be 9, 13, 17, 21. Once again, it's going to be discrete because we are not going to be paying any cents because the problem does not let us do that. So this wraps up the notes for today. Go ahead and stop the video and review your notes or see your teacher if you have any questions.